Please again, help me welcome warmly Dr. Quinn Lee.
Ever since I was a kid, I've lived two different yet connected lives. When I was growing up, I would spend my school year with my mom and stepdad in the sleepy suburbs of Calgary. And in the summers, I would hang out with my dad amongst a rough and tumble crowd in Southern Oregon, spending some warm summer nights with folks who had complex histories of addiction and mental health struggles too. And through these two lives I had growing up, I had the chance to learn how experience shapes who we are. And I started to feel that if you could share another's life experience, no matter who they were or where they came from, the reasons for their behavior, the places they did and didn't go, the choices that they would make, would reveal themselves. About a decade later, when I was 18, I was required through my university at the time to take an intro course in neuroscience. And when I came out of the very first class, I felt I understood the people I cared about more than ever and how their experiences shaped their behavior through changes that occurred in the brain. And the more I began to study the brain, the deeper I fell in love with trying to understand how it works and what it says about who we are as people. And what I came to learn is that you are your memories and that your experiences, your identity is encoded in memory and shapes the very way that you interact with the world. This is one of my favorite memories from that time, spending an afternoon in Silver Falls in Oregon. So I went on to study how memories are organized in the brain as a grad student and a postdoc, but I kept living two lives. During the day, I would pour my heart into my life as an aspiring neuroscientist, and on the evenings and weekends, I would play music gigs with friends among a different crowd. And through these two experiences, I got to travel lots to different places, interact with very different people, and I started to become really fascinated by how we learn and remember when our world changes. Specifically, how do we learn and remember across a lifetime of experience in a constantly changing world? This led me to work with mice, where we can study this at a really fine level of detail using modern technology to record neurons in the brain, record their activity, as animals are exploring, learning, remembering, and at a level of precision that is far beyond what we can achieve in humans today. So specifically, for example, here you're watching a top-down video of a mouse running around in a big square box. I know some people think this is kind of gross looking. But the little dots on the side are points in the body that we're tracking from this animal with modern machine vision technology. And in this same animal, I can simultaneously record the activity of hundreds of neurons using miniaturized microscopes and genetic tools that make neurons fluoresce when they're active, such as in the hippocampus. This video specifically is showing neurons activate in the hippocampus while the mouse is running around in that big square box. Every white dot here is a neuron emitting light when it becomes active. So really you're watching a light show of neurons talking to each other inside of a living, behaving mouse brain. But what's so special about these neurons in the hippocampus? Specifically, when animals and humans navigate a space, these neurons create maps of where we are and where we're going with their activity. Here I'm showing the activity of a single neuron with a heat map while a mouse explores an environment. And what you can see in this map is that this one neuron is active in a specific place in the environment, where there's that little yellow dot there. But what happens if we change the environment? Well, here's that same exact neuron, but when the shape of the environment has changed from a square into a rectangle shape. What you can see is that the map of the space in this single neuron adapts to the changing shape of the space. It kind of squishes with the environment. And this is known as remapping in the brain. And with modern techniques, we can record the activity of many, many of these maps, these neurons inside of the mouse hippocampus, at the same time. And so what we found is that these neurons in the hippocampus provide a highly reliable map of where the animal is and where it's going, even when the shape of the space is changing, is in constant flux, with the brain bending and stretching with the fluctuating form of space. So when I began to pursue these discoveries in neuroscience, machine learning and data science developed into artificial intelligence, which has taken front stage in many of our lives today. And as a neuroscientist, I started to think AI would be a really powerful tool to model how the brain learns and remembers in a changing world. But what we've learned as a field over decades of this work is that learning in a changing environment is a really tough problem that remains unsolved in artificial intelligence. Often these model systems tend to forget things that they've learned when their environments change, yet natural organisms adapt to a changing world every day. So with my colleagues and collaborators at the University of Alberta and the Alberta Machine Intelligence Institute, we've been designing artificial neural networks that learn to create these flexible maps of space, of an environment that adapt to a changing world, just like a mouse brain. Here I'm showing these maps of activity and neurons from the hippocampus on top inside of the mouse brain. And then on bottom, those are activity patterns of neurons in an artificial neural network. And you can see that there's a close semblance between how these two brains map this changing space. And as this work moves forward, we're trying to also build systems that are more efficient and directly compare these artificial agents from the neural to behavioral level with animals learning in a changing world. So today I continue to live two lives through my research. One version of me as a seasoned neuroscientist and another as an emerging AI researcher. And on one hand, my research team is trying to use AI as a powerful tool to model how memories are organized in the brain and learn about the brain. And on the other hand, we're trying to work toward understanding how learning in the brain could provide us with some answers to solve challenges in AI. More importantly, we know that change is something we will always have to confront in our lives, and many people struggle to adapt. And in pursuing these two connected lives, I hope that the result of this work will reveal not only how we could build better machines, but also uncover the brain mechanisms that shape how we remember in the face of change, and how we can help others better adapt, and what really makes you, you. Thanks.